Hello everybody. In this video we're going to talk about the first law of thermodynamics. Now the first law of thermodynamics states that the change in internal energy of the system is equal to the amount of heat added to the system minus the work done by the system. Now that's actually going to have two different versions for us, but it equates to a formula. Now the formula as it states, the change in internal energy, that delta U stands for internal energy, delta is a change in internal energy, is equal to the amount of heat or the quantity of heat added to the system, and the system is always a fluid, whether it's a gas or liquid, doesn't matter, the system's a fluid. The amount of heat added to the system minus the work done by the system. Notice we're using a minus here, that is if work is done by the system. Well, when does the system do work? The system is a fluid, so when does a fluid do work? Well, remember, work is force times distance. So basically, if you're blowing up a balloon, you're adding air to the interior of the balloon. That air is pushing on the inner walls of the balloon, causing it to expand. So that air inside is applying a force and is moving an object some distance. Perfect example of a fluid doing work. Now, we also have delta U equals Q plus W. Now, this is if work is done on the system. In other words, if you are stirring ice water, you're applying a force and you're moving an object, that being the fluid, some distance. Even if it's a circular distance, it's still a distance. So that's an example of work done on the system. And if that's the case, you're adding. Think of it this way, if the system is a fluid, you're adding heat to it, that's going to raise the level of energy. But if it's doing work, that's going to expend energy, therefore it's going to lose energy due to work. Here, if you're adding heat, naturally you're going to raise the level of energy. But if you're also doing work on it, you're adding energy to it. Thinking back to chapter 6, anytime you do work on a system, you're adding energy to that system. In this case, the system happens to be a fluid. And if you're doing work on it, you're adding energy to it. But if you remember, Q, quantity of heat is measured in calories, and work is measured in joules. There has to be a conversion, and this is it right here. Because to add or subtract quantities, they have to be the same unit. You can't take 2 kilometers plus 3 miles and get 5 kilometer miles. You have to convert them both to the same unit first. Likewise, for work and quantity of heat, 4.19 joules is equivalent to 1 calorie. So let's show you how we're going to use that in an example. Find the change in internal energy of a gas if 30 calories of heat is added while the gas does 13 joules of work on its surroundings. So first let's write our givens, make sure they're in the same units, and then look at which formula we're going to be using, the plus or the minus. So 30 calories, that's our quantity of heat, Q, while the gas does 13 joules of work, so 13 joules. Before we look at this, 30 calories, 13 joules, we have to convert. If I don't specify, either unit is fine. Convert all to calories or all to joules. Doesn't matter. It'll be the same for both. You'll have a different numerical answer, but they'll be equivalents. So we take our 13 joules, and 1 calorie at 4.19 joules, so therefore the joules cancel out, leaving the end unit of calories. Take 13 divided by 4.19, you get 3.10 calories. So in this case, I happen to convert both to calories. So now which formula do we use, the minus or the plus? Now we know 30 calories of heat is added, so that's our Q, while the gas does 13 joules of work. So the gas is doing the work, it's not work done on the gas. The gas is the fluid, therefore is the system. So the system is doing the work. The system is doing the work, that's work done by the system. We want to use the minus. So we start off with delta U equals Q minus W. We have delta U equals our 30 calories minus our 3.10 calories, which is the work the system's doing. We end up with 26.9 calories. So the change in internal energy of the system is a positive 26.9 calories. That means we've increased the amount of energy in the system. Now if we did an example where, say for instance, the work was much greater, say we had one where we were doing 40 calories of work. Well, 30 calories minus 40 calories gives us negative 10 calories. So the change in internal energy there would be negative, meaning overall lost energy. So if delta U is positive, overall you've added energy to the system, but if delta U is negative, overall you've lost energy. And that's how you use the first law of thermodynamics.